Good morning, class, and welcome to Lesson 4.1.2. Prior to the coronavirus situation, you were to complete 4.1.1. So just a quick review of what a polynomial equation tells you about a graph. We want to sketch the following polynomial without a calculator. Now, in order to sketch this, we need to take a look at some of the characteristics. First of all, we have a degree of a polynomial. The degree is 5, meaning we have an odd polynomial. The roots of the polynomial come from the two factors. So our roots are x equaling a -4 and x equaling a +1. So if we are to sketch this on our calculator, if we were to sketch this on graph paper, we have a root at 1 and a root at a -4. With this being of degree 5, meaning it's odd, it's going to start where an x is negative, y is going to be negative. So we're going to start down here and come up through our first root, which gives us a flattening at a -4. We're going to go up, peak somewhere, come down, and then bounce off of the root at 1. Because the root of 1 having a degree of 2, it creates a bounce effect in our graph. The root of x equaling -4 has a degree of 3. That creates a flattening at that root. So that would be a quick sketch. Now if you want to pause this and check it with your calculator, please do so. I will wait for just one moment for you to pause. Okay, welcome back. Now let's move into. Please take a moment to read and review what's on this page, and it's a photo of your math notes that can be found in chapter 4. Please note that it says the standard form equation of a second-degree polynomial is p of x equaling a times x squared plus bx plus c. This is a second degree because of this lead term has a degree of 2, or in other words, the term with the largest degree in this polynomial is of degree 2. Our standard form equation of a third degree cubic is going to be p of x equaling ax cubed plus bx squared plus cx plus d, where the lead term with the largest degree is 3. If we were to have a polynomial of degree n with coefficients a sub n minus 1, all the way down to a sub 1 and a sub 0, what those subscripts are telling us is they're just differentiating between your coefficients. So this could be the same as A, B, C, D, all the way down to Y, Z. If we had a 26 term or polynomial of degree 26. You could use all the letters of the alphabet if you wanted to, instead of using a sub n minus 1, all the way down to a sub 0. Polynomial would be written as p of x equaling a sub n times x to the n plus a sub n minus 1 times x to the n minus 1. This is just a very general form of what you see up above, where p of x is equal to ax squared plus bx plus c. So if we were to take a polynomial of degree 4, then the term with the largest exponent is going to be of degree 4. So p of x equals 7x to the 4th minus 5x cubed plus 3x squared plus 7x plus 8. Degree is 4, so n equals 4. A sub 4 would be the coefficient of 7. A sub 3, coefficient of negative 5. A sub 2, coefficient is 3. A sub 1, coefficient is 7. And your constant term, a sub 0, has a value of 8. So your goal in lesson 4.1.2 is to write the equations for graphs of polynomial functions given the x-intercepts in one additional point. So write an equation for each of the following polynomials without using your graphing calculator. When complete, check answers on your calculator. Hint, we want to write this in factored form. In order to do that, we need to identify the degree, the roots, and one additional point. So in part A, my roots happen to be x equaling a negative 3, x equaling 0, and x equaling 2. That gives me the factors for my polynomial p of x as x plus 3, x, and x minus 2. My a value let me rewrite this. My a value is what's going to uniquely determine this polynomial, because I could have infinitely many different graphs, such as the red one, that passes through those same roots. Or maybe it looks like this. So I need to uniquely determine, do I have the red equation, the blue equation, or the black equation? Well, in order to uniquely determine the black equation, I need to choose one point that's on the graph to help me determine my a value. That point is going to be 1, negative 4, where x is 1, y, or the output, is a negative 4. So I'm going to write an equation, negative 4 equals a times, wherever x is, I'm going to replace it with 1, and that's going to give me a negative 4 equaling a times 4 times 1 times a negative 1, which is a negative 4 equaling a times a negative 4. Divide both sides by a negative 4, and a comes out to be 1. So the equation for this polynomial, p of x, is 1 for my a value times x plus 3 times x minus 2. Now we should note that our exponents for our factors happen to be 1 because my graph if I can try to erase all of this. My graph passes through my roots, and therefore each root has to have a degree of 1. What I'd like you to do is pause this and come up with the equation for part B. Welcome back, and here's my work. This polynomial has a degree of 3 because it has a bounce at negative 2. It passes through 1. Therefore, it has to be a minimum of degree 3. 2 factors for x minus 2, 1 factor for x equaling 1. So using the roots negative 2 and 1, my polynomial has the equation of p of x equaling a times x plus 2 squared times x minus 1. Choosing a point on the graph, I've chosen the negative 1, 4. Plug a negative 1 in for x, plug 4 in for y, and then solve for a. A comes out to be a negative 2, and therefore your final equation is p of x equaling a negative 2 times x plus 2 squared times x minus 1. Here are 2 more. What I would like you to do is to pause this as soon as I'm done giving you a couple of hints, and then write the equations and compare your answers to what I have. My hints happen to be in part C, you have 2 roots at a negative 2 and at 1, where there's a bounce, therefore x equaling a negative 2, it has a degree of 3 by itself, a degree of 2 by itself, and at x equaling 1, you'll have a degree 1 minute. Also a degree of 2. So overall, this polynomial degree is 4. In part D, you have 3 roots, x equaling a negative 3, x equaling 0, and x equaling, sorry about that, and at x equaling 2, your degree is 1. At x equaling 3, negative 3, the degree is 1. And at x equaling 0, since there's a flattening, that degree has to be odd. So that's going to be of degree 3. So overall, this polynomial degree is 1 plus 1 plus 3 or 5. Use that to help write your equations. When you're done, come back and check your work. Welcome back. Please review the work. Notice in part C, I chose a point of a negative 1, negative 3 to help find my A value, and A came out to be a negative 1/3. So my polynomial P of x equals a negative 1/3 times x plus 2 squared times x minus 2 squared. In part D, polynomial's degree is 5 that we had mentioned, because the x plus 3 occurs as a factor once, the x minus 2 occurred as a factor once, and x occurred as a factor 3 times. So my equation has a times x plus 3 to raise to the power of 1, so we don't just write 1 up there, we leave that empty, x to the power of 3, and x minus 2 raised to the power of 1. The point chosen is highlighted in yellow, negative 1, negative 6, and so letting x be a negative 1, y be a negative 6, I found an A value that comes out to be a negative 1, and so my polynomial now is P of x equaling a negative 1 times x plus 3 times x cubed times x minus 2. Moving on to the next question. The graph of the polynomial bounces off the x-axis at negative 2, 0, crosses at 5, 0, and then passes through the point 1, negative 12. Sketch a graph and write a possible equation for this function. So making a graph, let me get a black pen. It bounces off a negative 2, 0. So I'm going to count by 2's. So each tick mark represents 2 units. So it bounces off at negative 2, 0. It's going to cross at 5, 0. And it passes through the point 1, negative 12, 2, 4, 6, 8, 10. And that's going to take me a little bit off of my graph paper. So, trying to sketch this where I have to pass through all 3 of these points, bounce off of this first point, pass through the point 1, negative 12, and pass through 5, 0. The degree of this polynomial is going to be of degree 3 because it bounces off, that gives me 2 factors, and it crosses or passes through, that gives me 1 factor. So that's going to be of degree 3. Odd degree polynomials, like the S curve for the equation y equaling x cubed, always starts low, and it's going to bounce off that point, pass through this point, and then come back up through 5, 0. So there's my sketch. My polynomial is going to be p of x equaling a times x plus 2 squared times x minus 5. My a value can be found by using that point, positive 1, negative 12. Y is a negative 12. A 1 plus 2 squared and 1 minus 5. So a negative 12 equals a times 3 squared, which is 9, times a negative 4. So a negative 12 equals a times a negative 36. Divide both sides by a negative 36. And a equals 1/3. So your equation, p of x equals 1/3 times x plus 2 squared times x minus 5. I hope you enjoy this. I think we're going to cut this lesson a little bit short, and what you need to take away from this is to find the exact equation of a polynomial from a graph. You need the roots, or your x-intercepts. You need the degree of the polynomial and the degree of those repeated roots. And lastly, you need a point so that you can uniquely determine the polynomial or to determine the a value. Hopefully this helps. Please remember that we do have office hours. Those office hours will vary by teacher. Best of luck, and look forward to seeing you in a Zoom meeting soon.